Alright, welcome to lesson 10-7. This is the volume of prisms and cylinders. You're going to need out a pencil, paper, colors, a calculator, and a ruler. By the end of this lesson, you're going to be able to find the volume of different prisms and find the volume of cylinders. So in science, we've talked about volume. We've learned about volume and density, and we've practiced finding the volume of different three-dimensional figures. And we've talked about that we use a graduated cylinder in order to measure volume. And that you would measure volume, it's in milliliters. But so now we're going to talk about it in math and use it to solve real life problems. So volume is essentially how much stuff is going to fill a given space, or how much room is in a given amount of space. So volume is a three-dimensional measure of space. It's the number of cubic units that are needed to fill it. So anytime you find the volume of an object, it's going to be, say, feet cubed. Area is always squared, but volume, you're taking three dimensions into account, so it needs to be cubed. So let's look at an example of what the definition looks like. So if you have a three-dimensional figure, we have here a rectangular prism. And so if I were to fill my rectangular prism, we'll first give it dimensions. 4 centimeters tall, 8 centimeters long, and 5 centimeters deep. Okay, so if I were to fill this with unit blocks, so 1 by 1 by 1 centimeter little blocks. The question is, how many of these 1 by 1 by 1 centimeter blocks are going to fill this large shape? Okay, so if I were to fill this up, these little blocks, could do a row across the bottom. It's actually a lot harder to draw than I thought it was going to be. But if you were to just draw one. Fill this big box with all these 1 inch by 1 inch by 1 inch deep blocks. How many would it take? And you can figure that out. You don't have to break this big box into all these small blocks and add it up. You can use the formula that volume equals the length times the width times the height. Because if you have a bunch of 1 inch blocks going across, well, if they're all 1 inch, that's going to be then 8 inches, right? And that's my length. And then if I have 1 inch cubes going back across my oh, that didn't turn out at all what it was supposed to look like. But if they're going back across my shape here in terms of depth, it's now 1, 2, right? All the way until it gets to 5. So it's going to be 5 deep. And then if I stack them on top of each other, I'm going to be getting, whoops, I didn't draw this very well. Well, it should be 4 tall if I was doing this to scale. because it's 4 centimeters, okay? So if I do 4 1 centimeter blocks, I'm going to have my total 4 inches. So instead of adding up all those little blocks, you can just plug it into the formula. Volume equals the length times the width times the height for a rectangular prism. So in this case, if I had my volume of, or not my volume, if I have my side length, right, I'm 5 centimeters deep, I'm 4 centimeters high, and 8 centimeters long, then I can plug that in and say the volume equals length times width times height. So the volume equals 5 times 8 times 4. So my volume equals 160 centimeters cubed. Centimeters times centimeters times centimeters is cubed. We have 3 centimeters we're multiplying by each other. Another way to write this formula is to say volume equals the base area times the height. And notice it's a capital B, so we're not talking about just the base length, but we're talking about the base area. You can use this then to find the volume of any prism. Because remember, every prism is going to have a different base area formula. And so if it was a triangular base, it's going to be different than my rectangular base. So here I could do my length times my width. My length times my width times my height. But if I had a triangular base, then I'm going to be doing my 1/2 base times height for my base area times the height again. Right, so that would be my volume for a triangular prism. My volume for the rectangular prism is length times width times height, because length times the width is the base area. This here, my 1/2 base times height is my base area, so it's just base area times height. So let's do a practice of that. Okay, I'm going to draw out my shape. Alright, so I have 6 feet, 8 feet, and 9 feet. Okay, so to find the volume of this triangular prism, wait, we have a triangle base. This is the triangular prism. I'm going to have to, so base area times height is the formula for volume. So my volume equals, my base area, remember, is the 1/2 base times height for a triangle. Triangle area equals 1/2 base times height. So I can plug that in. I can say, so my base area equals, well, my height, remember, is the altitude, is where that makes that right angle. So, 6 1/2, 1/2. My base length is going to be 8, and then my height is the 6th, that altitude where it makes the right angle at the base. So I'm going to plug this in for my base area. So I can plug in here the 1/2 times my 8 times 6. And then I'm going to look for, again, my height. My height in this case for the prism itself, it's 9 feet long. So I plug in 9 for my height. Now I'm just going to multiply it out. So 1/2 times 8 times 6. So 8 times 6 is 48 times 1/2, that's 24, times 9. So volume equals 24 times 9. 216 feet cubed. Alright, now we're going to practice finding the volume of a cylinder. So the volume of the cylinder is essentially the same way as the volume of a prism. It's still going to be volume equals base area times height. But a cylinder, just like the triangular prism has a different base area formula than the rectangular prism, the cylinder area, or the circle's area, equals pi r squared. So if our cylinder has a radius of 3.4 and a height of 12 centimeters, let's go ahead and plug that in and find our volume. So volume equals base area times height. So we're going to plug in, for the base area, we're going to plug in our circle area formula, pi r squared. So let's go ahead and write it out. So pi, we know r is right up here, distance from the center of your circle to any point on the side, so 3.4 centimeters, so pi times 3.4 squared. And then your height, how tall is your cylinder? Plug that in. So my height is 12 centimeters, so volume equals 3.4 squared times 12. I'm going to plug that in my calculator. 3.4 squared times 12 is 138.72. And then we still have pi. We haven't multiplied in pi yet. And so then if we use, for pi, we plug in 3.14 into our calculator, we get volume equals 435.58. So we'll round that to the nearest whole number, so volume equals 436. And with remember units, we did centimeters times centimeters times centimeters, so centimeters cubed. Alright, I'm going to have you do a practice problem now. I want you to find the volume of this cylinder. Okay, 2 feet and 5 feet. So find the volume. Hit pause on the video and then hit play when you're ready to find the answer. Alright, so the volume of this cylinder should have been 1900 feet cubed. I'm going to go ahead and do that really quick to show you. So volume equals base times height, base area times your height. So volume equals, well, circle area is pi r squared. So my base area, I'm going to do pi r squared. Now I have 22 feet as my diameter, right? 22 equals d. And your radius is 1/2 your diameter, so the radius is 11. So for my base area, I'm going to do pi times 11 squared. And then your height is 5 feet. So times 5. So volume equals pi 11 squared is 121 times 5. So volume equals pi times 605. So then volume equals pi, plug in 3.14. Multiply it out. So 605 times 3.14 is 1889.7. We're going to round to our nearest whole number. So the volume equals about 1900 feet. Feet times feet times feet, feet cubed. Alright, so you're in class problems. You're going to do so in class, you're going to be on page 541 in your textbook, and you're going to do numbers 7, 9, 11, and 18. And then your homework is going to be practice book page, or practice book 10-7 from your workbook. Alright, go ahead and get started on your in-class assignment.